practice question 1 is calculate the standard reduction potential of gold half cell. Inert cell is given positive 1.50 volt for, and also we have cell notation. Okay, this is a cell notation of hydrogen and our gold. So how to solve this problem? First step, we have to identify anode and cathode according to cell notation given. So according to cell notation given, double vertical line here is indicate salt bridge. Okay, salt bridge. This is a salt bridge. Okay, and then information at the left side is anode information at the right side, okay, is for cathode information. So after that, okay, we know that the information given, we have inert cell and then inert hydrogen. Inert hydrogen is 0.0 volt, is from standard reduction potential table. This value is come from standard reduction potential table. So next, we calculate inert gold according to this formula. Inert cell equal to inert cathode minus inert anode. Okay, so we have to substitute all information given, okay, into formula. Inert cell is given positive 1.5 volt. Inert cathode is stand for inert gold. Okay, so inert gold we have to calculate minus inert hydrogen. Inert hydrogen value is 0. So after that, we will get the answer. Positive 1.5 volt. Okay, look at the practice question 2. Practice question 2, calculate the standard reduction potential of ferrum half cell. Inert cell is given positive 0.44 volt for. Okay, so then here we also have cell notation. Okay, so what we have to do, of course, we have to identify anode and cathode according to cell notation given. Okay, don't forget this is a double vertical line is stand for salt bridge. Okay, and then we have anode information at the left side and cathode information at the right side. Also given inert cell and then inert hydrogen equal to 0 is we will get this value in standard reduction potential table 0 volt. So by using formula, we substitute information given in this formula. Inert cell is positive 0.44 and inert hydrogen, which is at cathode, equal to 0. And now we can calculate inert anode. So inert iron ferrum is negative 0.44 volt. Next, practice question 3. Okay, in this practice question 3, we have cell notation and inert cell also given. So in this practice, we have 3 questions. A, calculate the standard reduction potential of chlorine half cell. Chlorine half cell. Okay. B, draw a diagram to show the apparatus and chemical use. And C, write the overall equation. So we solve this problem one by one. A first, calculate standard reduction potential. Standard reduction potential is inert cell. Inert cell, by using inert cell equation, we can calculate standard reduction potential of chlorine. Okay, so of course, okay, according to this cell notation, we have a double vertical line stand for salt bridge. Okay, and then anode information at the left side and cathode information is right side. Okay, so anode cell is given positive 2.87 volt, and anode hydrogen we get from standard reduction potential table equal to 0. Okay, by using formula anode cell, anode equal to anode cathode minus anode anode. So anode cell is positive 2.87 volt. Anode cathode we have to calculate, and then anode is 0. So after that we will get the final answer is positive 2.87 volt. Okay, B, draw a diagram to show the apparatus and chemical use. Alright, so this is a diagram to show the apparatus and chemical use. Okay, according to this diagram, okay, look at your answer, class. Okay, your drawing must have 2 beaker contain 2 electrolyte. Okay, so electrolyte we indicate as electrolyte, 2 beaker contain 2 electrolyte. So electrolyte must be draw like this lah, mesti ada benda ni. Sebab dia nak indicate electrolyte. Okay, and then this is a galvanic cell. Okay, normally we draw substance at anode at the left side. Okay, so anode is hydrogen. So we have tube. Okay, and then we have to draw hydrogen gas 1 atm flow in tube. Okay, so electrolyte we have to label H plus aqueous, and condition is 1 molar and 25 degrees Celsius. And then we use inert electrode, which is platinum. We choose platinum here. Okay, as a electrode. Okay, connected into the wire. Okay, connected with a 2 voltmeter. And then, okay, at the cathode we have also platinum electrode here. And then electrolyte we label as F minus aqueous 1 molar. Okay, after that, fluorine gas is flow out from tube. Okay, 1 atm. So next, we have to draw salt bridge in between 2 beaker, and then we have to know what is the function of salt bridge. Okay, so function of salt bridge is maintain neutrality. Okay, so bila function salt bridge maintain neutrality. Okay, so look at the beaker for anode. Anode, hydrogen gas will release electron. So electron will flow into wire from anode to cathode. Okay, after that, H2 gas is produced H+. So dalam beaker anode ni adanya H+. Kan, reaction dia okay, ada H+. So bila ada H+ kat sini, okay, dia punya solution dalam beaker ni, medium dalam beaker anode ni, dia ada abundance of positively charged. So macam mana kita nak neutralkan dia? Salt bridge kita ni anion yang akan, bukan cation ya, anion yang akan flow into anode beaker. Cation flow into cathode, okay, to maintain neutrality. So bila an ion is negatively charged, so dia akan maintainkan dia punya neutrality pada anode. Dan juga bila cation, kan, pada cathode ni kan dia terima elektron kan. So bila dia terima elektron, okay, F2 gas accept elektron, kat sini ada negative charge yang banyak, abundance of negatively charged. So salt bridge ni dia akan dia akan flow into the cathode beaker, nak maintainkan neutrality. So kat sini hati-hati ya, an ion negatively charged dia akan flow into anode, cation positively charged dia akan flow into cathode. So berapa markah kat sini kita akan dapat? Markahnya adalah kat sini ada satu markah untuk ada beaker, ada electrolyte, and ni kita label electrolyte tu. So satu markah kat sini. Lepas tu kita ada electrode apa kita pakai. And then kita punya tube untuk hydrogen gas, and ada punya labeling. Flow of electron, kena tunjuk flow of electron kita from anode to cathode, flow of electron, voltmeter pun kena tunjuk. And then kita punya beaker of cathode, electrolyte dia, dan juga labeling of electrolyte 1 mark. Electrode for iron, for fluorine, platinum 1 mark, and then label tube dan juga fluorine gas, 1 mark. Don't forget salt bridge also 1 mark. Next C. C, the question asking for write the overall equation. According to cell notation, we have fluorine gas at the cathode. So fluorine gas will accept electron here. Kat sini fluorine gas kan terima elektron, so dia akan hasilkan 2F minus. So make sure kita balance lah equation kita. So now kita perlu tulis overall equation. So bila kita punya total elektron kita sama, boleh cancel out, so kita akan dapatlah overall equation. Practice question 4. For the following, half cell was connected to she. Given half cell equation and inert value of iron, we have 4 questions, A, B, C, D. A, write overall equation. B, write cell notation. C, calculate inert cell. And D, draw setup of when connected to she. A, to write overall equation, of course we have to write half cell equation first. This is because hydrogen is value, inert value is 0 volt, while inert value for iron 3 plus, iron 2 plus is positive 0.771, which is more positive. So that means iron undergoes reduction at cathode, and hydrogen undergoes oxidation at anode. So half cell equation must have inert value of hydrogen 0.00 volt and inert value of iron positive 0.771 volt. After that kita boleh cancel out number of electrons sebab kat sama. Cancel out. Then kita akan dapat overall equation. So marks here 3 marks. B. B, cell notation as it is. So at the left side we have hydrogen because anode, right side cathode because iron. C, calculation of inert cell. Formula 1 mark, and then final answer 1 mark. Diagram as it is. Alright. So now marks here for electrolyte, electrode. Tube for hydrogen. Flow of electron from anode to cathode. Voltmeter. Electrolyte at cathode, electrode at cathode, and salt bridge. So salt bridge, an ion flow into anode, cation flow into cathode. Practice question 5. For the following, half cell was connected to standard hydrogen electrode. Given half cell equation for bromine liquid accept 2 electron, produce Br minus ion aqueous, and also given E naught value for this reaction positive 1.07 volt. We have 4 questions in this practice. Is A, write the overall equation, B, write the cell notation, C, calculate E naught cell, and D, draw the setup of when connected to standard hydrogen electrode. So we settle one by one. A, first write the overall equation. So write overall equation, we have to identify anode or cathode, or we have to identify which substance undergoes oxidation at anode and which substance undergoes reduction at cathode. So how do we determine? We have to understand what information given in question. Given that half cell was connected to She, that means the system, the cell is involving between hydrogen and bromine liquid. After that, we look at the E naught value for each substance. Hydrogen, E naught for hydrogen, of course, 0 volt. Okay, 0 volt. And then, E naught for bromine is positive 1.07. So from both value, we have to identify which value is more positive. Okay, we look at here. Okay, bromine, E naught bromine is more positive than E naught hydrogen. So that's why bromine is undergoes reduction at cathode and hydrogen oxidized at anode. After that, we have to write half cell equation at anode and cathode. So anode, hydrogen release electron, okay, and then will form H plus. So we have to balance equation. So then don't forget to write E naught value for hydrogen is 0.00 volt. At cathode, bromine undergoes reduction. That means Br2 liquid accept electron to form Br minus. Okay. So then we write E naught value for bromine, which is positive 1.07 volt. So to write overall equation, okay, we have to cancel out number of electron. So both half cell equation have same number of electrons, so we cancel out. After that, we will get overall equation. So how to get the marks here? Half cell equation at anode with E naught value is 1 mark. Half cell equation at cathode with E naught value 1 mark. After that, overall equation 1 mark. Okay, B, write the cell notation. Cell notation, we have to write anode at the left side. Okay, first kena tulis kita punya electrode. Okay, oleh kerana at anode, kita punya hydrogen tu adalah dalam gas phase, kita mesti menggunakan inert electrode. B, write the cell notation. Cell notation, we have to write according to half cell equation. This answer is wrong. The correct answer is we use inert electrode, solid, and then single vertical line. Okay, we have hydrogen gas. Condition is 1 atm. Okay, and then single vertical line, we have H plus. In aqueous phase, double vertical line. Don't forget to write condition for H plus 1 molar, double vertical line. Okay, Br2 is liquid phase, 1 molar, followed by Br minus aqueous 1 molar, and then inert electrode platinum. Okay, so how to get the marks here? Okay, anode 1 mark at the left side. Okay, from anode, Hausdorff equation anode 1 mark, and the right side from cathode, Hausdorff equation at cathode. Okay, C, calculate E naught cell. So by using this formula, E naught cell equal to E naught cathode minus E naught anode. Alright, so cathode is positive 1.07 volt and anode is 0. The answer is positive 1.07 volt. Next, D. D is diagram the setup of when connected to standard hydrogen electrode. So hydrogen at anode, bromine at cathode. So the diagram as it is. So the marks here, okay, for electrolyte, anode, okay, H plus, okay, and phase aqueous and 1 molar concentration. Electrode of hydrogen, we use platinum. We have tube, okay, tube for hydrogen gas flow in and condition 1 atm. So after that we have flow of electron from anode to cathode. Okay, 1 mark. Voltmeter 1 mark. Okay, and then electrode at cathode 1 mark. Electrolyte at cathode 1 mark. And salt bridge. Salt bridge, we have to label an ion flow in anode system and cation flow in cathode. So 1 mark for salt bridge. Practice question 6. Which species in each pair is a better oxidizing agent under standard state conditions? So better oxidizing agent, that means the substance undergoes reduction. Okay, so to solve this problem, we have to use standard reduction potential table to get E naught value for each substance. A, Br2 or aurum ion. Okay, according to standard reduction potential table, Br2 gas for E naught is positive 1.08 volt. And aurum ion is positive 1.5 volt. So we have to compare which value is more positive. The answer is aurum ion. So kenapa kena ambil yang more positive? Why we choose the substance has more positive value? Because the substance has more positive value indicate the substance is higher ability to accept electron. Okay, so that's why when the substance higher ability to accept electron, that means the substance undergoes reduction. So bila kita punya substance undergoes reduction, that means dia adalah better oxidizing agent. Okay, same goes to B, H plus or Ag plus. So according to standard reduction potential table, H plus value for E naught is 0 volt and Ag plus is positive 0.8. So Ag plus has more positive value. That means Ag plus undergoes reduction, which is better oxidizing agent. C, cadmium ion or chromium ion? The answer is cadmium ion. Okay, because cadmium ion has more positive value of E naught. That means cadmium undergoes reduction, which is better oxidizing agent. Lastly, oxygen in acidic medium or oxygen in basic medium is better oxidizing agent. The answer is, okay, lastly is D. Oxygen in acidic medium or oxygen in a basic medium has better oxidizing agent. The answer is oxygen in acidic medium because, okay, value E naught for oxygen in acidic medium is more positive compared to oxygen in basic medium. How to get this both value? We have to refer standard reaction potential table. So awak ambil cara nak tengok nilai ni, awak ambil oxygen in acidic medium, awak kena ambil equation yang ada oksigen. Okey, yang kat situ juga dia mesti ada H+. Sebab H+ tu menunjukkan dia acidic. Kalau untuk ambil value oxygen in basic medium ni pula, awak ambil oksigen yang dalam equation tu adanya OH-. Alright, so next, practice question 7. Which species in each pair is a better reducing agent? Better reducing agent. That means the substance undergoes oxidation. Okay, so the steps as practice question 6, we will have to get value of E0 for each substance given and then compare. Lithium undergoes oxidation, which is better reducing agent. Okay, B, the answer is hydrogen. C, the answer is Fe2+. Fe2+. And lastly, the answer is bromine ion. Practice question 8. Practice question 8. Given standard electrode potentials for Ag+, Ag and Pb2+, Pb are respectively 0.799 and negative 0.126 volt. Determine the anode and the cathode. Okay, so from this, from information given, okay, we list out that E0 for each substance, silver and plumbum. So Pb2 plus negative 0.126 volt. Alright. So from both E0 value, we have to compare which substance is more positive value. The answer is silver. So that means silver undergoes reduction at cathode. And then plumber undergoes oxidation at anode. Alright. So from this, okay, and then the answer is anode plumbum, cathode silver. Alright. So B, calculate standard cell potential. We use formula. Okay. So by using this formula, kita masih straightforward use in E0 given. For E0 cathode is positive 0.799 volt minus E0 anode is minus negative 0.126 volt. The answer is positive 0.925 volt. Practice question 9. We have overall equation and E0 cell. The standard reduction potential for cobalt ion is negative 0.28 volt. Calculate standard reduction potential for the change of Ce2+ to Ce3+. Alright, so next, the standard reduction potential for the change Ce4+ to Ce3+, reduction occurs as cathode. Sebab dia dah bagi tahu dia nak kita kira calculate untuk Ce4+ to Ce3+. That means dia undergoes reduction at cathode. Alright. So that means cobalt ion act as anode. Alright. So kita pun substitute value dalam E0 cell equation. After that kita akan dapatlah positive 1.61 volt. Practice question 10. Predict whether the reaction below will occur spontaneously in aqueous solution at 25 degrees Celsius. Assume that the initial concentration of the dissolved species are all 1 molar. Given overall equation for calcium and cadmium. Alright, so to determine spontaneity of the cell, we have to determine E0 cell, because the condition here is 25 degrees Celsius for temperature and concentration 1 molar. Okay, boleh faham tak? Sekarang ni kita nak tentukan spontaneity of the cell mesti depends kepada E0 cell. Why from E0 cell? Because dia dah bagi tahu condition kat sini temperature 25 degrees Celsius and kita punya concentration 1 molar. So that's why kita kena tentukan daripada E0 cell. Kena kira E0 cell. Kalau dapat positif, spontaneously ataupun spontaneous. And then kalau dapat negatif, that's mean non-spontaneous. Alright, so next. Kita tengok. Calcium produce calcium ion. So that's mean kat sini undergoes oxidation. Okay, and then cadmium ion produce cadmium solid. That means this reaction undergoes reduction. Okay, so what should we do? So we have to refer standard reaction potential table to get E0 value. So E0 cell formula is E0 cathode minus E0 anode. So now, which one is cathode? So according to overall equation here, okay, cathode is cadmium ion produce cadmium solid because CD2 plus, okay, produce CD. That means the reaction is undergoes reduction. So this one is cathode. Calcium to Ca2 plus undergoes at anode. So cathode is negative 0.40 volt. You have to use this value from SRP table, standard reaction potential table. Anode is calcium. So according to SRP table, standard reaction potential table, calcium E0 is negative 2.87. So straightforward substitute in this formula. After that, you get positive of value, positive 2.47. That means the reaction is spontaneously. Okay, practice question 11. Same goes to practice question 10. Okay, alright. So next kita tengok practice question 11. Okay, Br minus produce Br2, Sn2 plus produce Sn. Sn2 plus produce Sn. That means undergoes reduction. Okay, at cathode. And then Br minus oxidize at anode. So cathode minus anode. Okay. And then substitute value. Both value kita mesti tengok SRP table. So finally we get negative 1.22 volt. That means non-spontaneous. Practice question 12. Based on the cell notation below, write a balanced equation for the spontaneous reaction in the cell. Alright. B named oxidizing agent. C calculate E0 M3 plus M. Okay. From cell notation given, we have anode. Okay. Silver at anode. M at cathode. Write balance equation. Okay, now we write overall equation. So overall equation, we have to write half cell equation first. Half cell equation for A at anode, silver solid produce Ag plus ion and electron. At cathode, M3 plus metal ataupun sorry, at cathode, M3 plus aqueous accept electron to form M solid. Okay, the reaction is, okay, now we have to balance half cell equation at cathode first. Alright, overall equation. Okay, we have to cancel out number of electron. For silver, we have to multiply with 3. So now we have 3 Ag plus M3 plus equals, number of electrons cancel out, produce 3 Ag plus and M solid. Okay. So this is the answer. Okay. Next, name the oxidizing agent. Oxidizing agent, that means the substance undergoes reduction. Okay, reduction. Okay. So which substance undergoes reduction? The answer is here. Okay. So M3 plus is the oxidizing agent. Why? Because M3 plus accept electron. Because M3 plus undergoes reduction. Okay, the answer should be right as it is M3 positive. Calculate E naught. Okay, we have to calculate E naught and naught. E naught cathode. So E naught cell equal to E naught cathode minus E naught anode, 1 mark. And then E naught cell is given 1 volt equal to E naught cathode. We have to calculate minus E naught anode. E naught anode is given 0.8 volts. So